This video will explain how and why to use loops in R. So suppose we have three data files called A, B, and C.csv, and each contains a set of observations we've made of some variable called x, and we want to compute the mean value of x for each file. So it's easy enough to do this for just one file. We would read the CSV and then print the mean value of the x column for that file. And then to do this for the other files, we could just copy and paste the code we've written, which works for one file, and change the value of the file name, first to B and then to C. And this works, but it's not ideal. Because if we wanted to, say, compute the median instead of the mean, we would have to change each instance of mean to median. And it's easy enough to do this on such a small script, but if we were working with a really large script that had a lot of code in between each of these sets of statements, it would be easy to forget one, and then we would have an error in our code. A better way of doing things would be to write our code once and then have R execute it repeatedly. So the way to do that is to write repeat, followed by a set of curly brackets. And any code we put between these curly brackets will be repeatedly executed by R. So let's copy in the code that works for just one file. So we want this code to repeatedly execute, but each time it executes, we want it to use a different file name. First, we want it to use the file name a.csv, then b.csv, and then c. So let's create a counter variable called current index. And we'll use this inside of the repeat loop to keep track of which file we're currently reading from. We'll give it an initial value of 1 because we want to start with the first file. Let's also organize our file names into a vector, like so. With our file names organized this way, we can access the current file by indexing file names at the current index. So when current index is 1, current file will be a.csv. When current index is 2, current file will be b.csv, and so on. So let's print out the name of the current file, just to make sure this is working properly. And so now, instead of reading a.csv every time this code runs, we instead want to read the current file, whatever that ends up being. And once we've read one file, we want to move on to the next one. And the way to do this is by incrementing our counter variable current index by 1. So we would write current index gets its previous value plus 1. So after this code has run the first time, current index will be incremented from 1 to 2. So when the code runs the second time, current index will have a value of 2, so current file will be b.csv. Then when this code runs the third time, current index will have a value of 3, and current file will be c.csv. At this point, we want our loop to stop. We want our code to stop as soon as the value of current index becomes greater than the number of files that we have. So the way we would write this in code is if the current index is greater than the number of files that we have, which in this case is the length of our vector of file names, then break out of the repeat loop. So let's give this a try and see what happens. So sure enough, each time the code runs, current file is taking on a different value. First a.csv, then b.csv, and then c. And the numerical values we're getting are different each time. So we know we're not just reading the same file over and over again. The advantage of writing code this way is if we changed our mind again and wanted to compute the mean instead of the median, we would only need to make this change in one place. And so there's much less probability of error. Also, suppose we were to add another file called d.csv. So see, now there's a file called d.csv. So to handle this file the same way as we handled the other ones, rather than having to write a whole lot of new code, we could instead just add d.csv to our vector of file names. And now when we run the code again, d.csv gets handled the exact same as the other ones. So another way of implementing the same procedure would be to use a while loop. And a while loop essentially uses the opposite logic of a repeat loop. A repeat loop says, repeat some instructions until some condition becomes true. A while loop, on the other hand, says, repeat some instructions for as long as some condition remains true. So rather than saying, stop the loop once current index is greater than the number of files we have, we could instead say, repeat the loop for as long as current index is less than or equal to the number of files we have. Let's see how we would do this. So we could write while, followed by a set of round brackets. And in these round brackets, we specify the condition that has to remain true for the code to keep repeating. In this case, like we were saying, this condition would be current index has to be less than or equal to the number of files we have. And then we add a pair of curly brackets, and all of the code between these curly brackets will be repeated. So let's copy in the code from our repeat loop, except for the part that was specific to the repeat loop, which is the part that breaks us out of it. So now, when we run this code again, first resetting the current index variable, we get the same results as before. Current file takes on first the value a.csv, then b, c, then d. And again, the numerical values that are printed out are different every time. It's the same way of implementing the same, or it's a different way of implementing the same procedure, just using this sort of flipped logic. A third way of implementing this procedure would be to use a for loop. A for loop says, repeat some instructions, but each time you do, use a different value for some loop variable. So in our case, we have a variable called current file that takes on a different value each time the code is repeated. First, it takes on the value a.csv, then b.csv, then c, then d. And the reason it does this is because we have this counter variable called current index that gets incremented each time the code repeats. A for loop would allow us to specify at the very beginning which values our loop variable current file should take on. Let's see how we would do this. So we would write for current index, or sorry, for current file, so the name of our loop variable, in the set of values that we want our loop variable to take on, which in this case is our vector of file names. And then we write a pair of curly brackets, and then all of the code within the curly brackets gets repeated. But each time it gets repeated, current file will have a different value within the vector of file names. So let's copy some of the code from our while loop into our for loop. Notice how we're omitting the line that assigns a value to current file. We don't need to do this anymore because we're already specifying which values current file should be assigned. They're the values within the vector of file names. We're also omitting the line that increments our counter variable current index. And this is because we're not using current index anymore. So when we run this for loop, the results are the same as before. Each time this code repeats, our loop variable current file takes on a different value. First a.csv, then b.csv, then c, and then d. And again, the numerical values are different each time. And this is because we've specified when we were writing the loop, which collection of values we want our loop variable to take on. In this case, we want current file to take on each value in our vector of file names. First a.csv, then b.csv, then c, and then d. So this is 3 different ways of implementing the same procedure using a repeat, a while, and a for loop. So hopefully this video helped you understand how and why you might want to use loops in R. Thanks for watching.